6.7, let f be a continuous, I'm going to reinterpret theorem 6.7. Let G be a continuous function from a compact space to a Hausdorff space. If f is 1 to 1, then f is a homeomorphism of x and its image. So in other words, bingo, G is a homeomorphism. Y actually does not need to be compact, no. But I think it has to be in order for f to be continuous. If x is continuous, if x is compact and onto, then f of x is equal to y, which means that y is compact. So, but yeah, you could strip off the Hausdorff from the. You can strip off the compactness of y from the assumptions, but it would just it would still need to be. So sorry I got a slightly late start today. I really want to finish this section. If you guys just give me 2 minutes extra, understand that it's a great personal risk that I take these 2 minutes. Not you guys. This is a beautiful example, right? Because we go back to the picture I drew at the start. Now it's explicit mathematics to construct the circle by gluing together the ends of the unit interval. And the way to do it is simply with he lets y, how's he do it? Y equals to 0, 1 mod the equivalence that we talked about before. Specifically, here it is, finally. F mapping 0, 1 to the circle by f of t equals e to the 2 pi I t. All right? So we're viewing the circle as a subset of the complex numbers, okay? And so this function for 0 less than or equal to t less than or equal to 1. So what does this do? Yeah, I mean it takes the interval 0 to 1, right? And it does what? The counter, like you said, counterclockwise. It moves both the f of 0 equals f of 1 equals 1. And otherwise, if you pick the inverse, so like the inverse image of any point over here, p, right? Let me say the inverse image of e to the I theta, yeah, is what? Theta over 2 pi? You know, for theta not equal to 0. And then the inverse image of 1 is what? It's 0 and 1. So that glues 0 and 1 together. It's a continuous map, right? And going from compact Hausdorff to compact Hausdorff. And so this proves that, what? What does this prove? That the quotient of taking the unit interval and gluing the endpoints together is homeomorphic to the circle. Not a fuzzy picture, not a proof by picture, a proof by explicit point set topology. Very nice, and not that hard. And then the next example he has is of the torus. But we'll start next class there. It's good to do that again to emphasize the importance of this theorem. So, Hey, look, I was only a minute over. Woo! You guys got me talking about philosophy and everything.